Hey guys, here is your video to help you with the extension concept for inscribed angles. It's actually not just inscribing an angle. Okay, so like here's your inscribed angle like in the last video, but I'm actually going to make a quadrilateral out of this. A quadrilateral out of this. Alright, so you've got an inscribed angle here. I'm going to draw another inscribed angle here, and then I will connect them like this. Okay, so I have all four, right? All four vertices are actually on the circle. So I have an inscribed angle here, 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 and here. They're all inscribed, and that makes the inscribed quadrilateral. Okay, let's label this A, B, C, D, and let's actually even give it little letters to represent the angles. Let's go, I don't know, how about W, X, Y, and Z. Okay. So if you watch the inscribed angle video or you understand the inscribed angles concept, then it shouldn't be too much to sell you on the fact that this arc that goes all the way from here to here is intercepted by this angle. Okay, so angle A, if you focus your eyes in on just angle A, then the arc that hits is BCD. Certainly looks like a major arc. I didn't put any numbers in, but it definitely looks like a major arc, right? So in this case, angle BAD, which is angle A, intercepts arc BCD. Now, if the measure of angle A is W, then what would you expect the measure of this arc to be? Well, hopefully you doubled that, because we know the inscribed angle, when you double it, you get the intercepted arc. So actually the measure of this intercepted arc is 2W. Okay? Let's go the other way. Let's focus your eyes in on angle Y. Okay, I'll switch color. Actually, I'll keep that one black. Angle C, I mean, where the Y is. Angle C is this black one. Okay? And that intercepts arc BD. Okay, this one looks minor, so I don't even need to mention the A. I could say arc BAD. It's not the end of the world, but it's really just arc BD. So if this is Y degrees, then the measure of this arc would be double that, 2Y degrees. So again, focus your eyes on this angle and see the arc that it hits, which is right here. And if this angle is Y, this would be 2Y. If this was 20, this would be 40. If this was 50, this would be 100, etc., etc. And do the same thing here. Okay? The angle here, W, gets doubled to make the arc. Now here's the connection. This entire circle, of course, is 360 degrees. So that means the 2W and the 2Y, which make up the entire circle, must equal 360 degrees. 2W takes care of this, 2Y takes care of this. A full circle is 360. Divide the whole thing by 2. Divide left side by 2, everything. Divide the right side by 2, and you get the 2's will cancel, and you get 180. W plus Y equals 180. W plus Y equals 180 degrees. Right? 2W divided by 2, 2Y divided by 2, 360 divided by 2. If you want to write it differently, if you don't like the way that I wrote it there, you could write it like this if you want. Maybe this will help. Divide everything by 2. You can't just divide one thing by 2 without doing everything by 2. And now you'll see W plus Y equals 180. What does that mean? That means that angle W and angle Y must be supplementary. So if you know this angle, let's say this angle is 100 degrees, you could instantly find this angle by understanding this concept. W and Y must add up to 180, so if this is 100, well then that's got to be 80. Now I have no idea what these are yet because I didn't make anything up, but you know what? I could do the same proof, the same explanation, and get these two adding up to 180. So let's say this one is 110, just to give it a number. Well, if this is 110, how much is left over for this one? Well, 110 from 180 leaves you with 70, and you can check your answers because all of these should add up to 360. Okay? So here's the main idea. Opposite angles, the ones that are across from each other, are always supplementary. Opposite angles are always supplementary if you have a quadrilateral inscribed in a circle. And that's the last major, extension of this idea. Okay? In fact, if you look on your notes sheet, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. That's a fancy way of basically just saying what I just did. These two angles add up to 180. These two angles add up to 180 in this scenario. All right, let's look at an example and try it out. Let's look at actually the one on the sheet. Actually, that's a little fuzzy. Maybe I can zoom in a little bit. This is example number 5 from your worksheet, 5A. Okay. So we have a wow, my hands look ridiculous in this. You have a circle, of course. You have the inscribed quadrilateral. If this, I didn't mean to pick the same number, but look at that. If that's 110, and you go across, then this has to be 70, because 110 plus angle P must equal, or P degrees must equal 180. So P has to equal 70. Okay, do it the other way. If this one is 95, there's only so much left over for this one. This one's got to be 85 degrees, because 85 plus 95 is 180. And that's all you have to do. Okay, so main idea is still the inscribed angle idea. Okay, main idea is the inscribed angle, that the W here is doubled to get the arc, or if you look at the arc, you could divide by 2 to get the angle. But in this special case, the opposite angles actually add up to 180, and that works every time. Okay, hopefully that helps. Let me know if you have any questions, and I will talk to you guys later.